Now, of course, when you're working in the laboratory, you generally don't know how many moles you have. You need something more measurable, like molarity, which will be given to you, or volume, measuring out how many milliliters of acid it takes to neutralize how many milliliters of base. Now, if you remember, we said that molarity was equal to moles divided by liters. Well, if that's the case, moles is equal to molarity times liters, which means moles of acid would be the molarity of the acid times how many liters of acid you have. Mala! And that would mean that moles of base is equal to the molarity of the base times how many liters of base you have. Now, here's the great thing about neutralization reactions. You don't actually have to convert your volumes to liters, because if they're in milliliters, the unit will just cancel out. So you don't even have to convert milliliters to liters. It's amazing. So instead of saying liters of acid, we could just simply say volume of acid, volume of base. So because moles of acid is the same thing as molarity times volume of acid, and moles of base is the same thing as molarity times volume of base, we can use this equation instead of that if we're actually doing it in the lab. Or as I like to call it, mava equals mverb. Mava, it equals mverb, it equals mverb, it equals mverb, mava, it equals mava, mava, it equals mava, it equals mava, 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 it equals 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 mverb. Of course, I don't recommend you do that during a test, so you can find the titration equation on the back on reference table T. Okay, here's some sample problems. How many milliliters of 0.1 molar NaOH are needed to neutralize 20 milliliters of 0.5 molar HCl? Well, it's handy to circle everything that involves the base and everything that involves the acid. This way it separates everything out and makes it easier to solve the problem. How do I know this is the base? Because the formula's got OH in it. How do I know this stuff is for the acid? Because it starts with hydrogen. So the equation is number of H's mava equals number of OH's mvb. And we're asked how many milliliters of base do we have? We want to know the volume of the base. So we divide both sides by number of OH's mb, and they cancel out. And then we can simply plug in. How many hydrogens in the formula of the acid HCl? 1. What's the molarity of the acid? 0.500. What's the volume of the acid? 20.00 milliliters. Over. How many hydroxides in the formula of sodium hydroxide? That would be 1 hydroxide. The molarity of the base is 0.100. Check it out. Molarity cancels. It's going to leave us with milliliters, which is what we're trying to find out. Now we could plug this into a calculator and say 0.5 times 20 is 10, 10 divided by 0.1 is 100. Or we could say 0.5 and 0.1 simplifies to 5 over 1. 5 times 20 is 100 decimal point milliliters. 3 sig figs, 4 sig figs, 3 sig figs, so 3 sig figs in the answer. That means we're going to need 100 milliliters of our base to neutralize 20 milliliters of our acid. It takes 45.0 milliliters of 2.0 molar H2SO4 solution. Well, this starts with hydrogen, that means that's our acid. To completely neutralize 30.0 milliliters of an NaOH solution, what is the molarity of the base? That's all the stuff we need about the base. So the formula is number of H's mava equals number of OH's mvb. And we're trying to find the molarity of the base. We need to find mb, molarity of the base. So we divide both sides by number of OH's bub. Number of OH's bub. Say goodbye, say goodbye. Now you're ready to solve the problem. How many hydrogens are there in the formula of the acid H2SO4? Well, that would be 2, I guess. The molarity of the acid is 2.0 molar. The volume of the acid is 45.0 milliliters divided by How many OHs in the formula of the base, NaOH? That would be 1. And the volume of the base in question is 30.0 milliliters. So milliliters cancel and leaves us with molar, which is what we're trying to find out. And this comes out to 6. Let's see, 2 sig figs, 3 sig figs, 3 sig figs, that's 2 sig figs, and so that's 6.0 molar. I hear you screaming. You know, you may be playing this on YouTube, but I can still hear you screaming, but those guys only have one significant figure. Well, actually they don't. They have infinite sig figs. You see, these are measurements. That's not. We just count it. There's 2 H's. There's no uncertainty about that. There's 2.0000000000000 to infinity hydrogens. It's sort of like saying, I have 2 arms. How many sig figs are you going to give to that? It's like saying, hey, I've got 2 arms. Is that 1 sig fig? Or do I have exactly 2 arms? There's no uncertainty. Here's 1 arm, there's the other arm. No arm, no foul. Oh! Another kind of problem you can have is the mixed moles and molarity problem. Now remember, MAVA is the same thing as saying moles of acid, and MUBVUB is the same thing as saying moles of base. So you can substitute them in as necessary. You can say number of H's times moles of acid equals number of OH's MUBVUB, or you can say number of H's MAVA equals number of OH's times moles of base. You can use moles of acid or moles of base interchangeably with MAVA or MUBVUB. So this says how many moles of HCl are needed to neutralize 50.0 milliliters of 0.100 molar CaOH2. So this is the stuff about the acids, this is the stuff about the base. Okay, now because we're solving for moles, we're not going to be able to cancel out the milliliters, so we need to convert the milliliters to liters before we solve the problem. 50.0 milliliters is 0.0500 liters. Okay, if I had milliliters on this side and milliliters on that side, the unit would cancel and I wouldn't have to worry about converting it. But because I don't have milliliters on this side and moles is molarity times liters, I have to convert my milliliters to liters first before I can solve the problem. Number of H's MAVA equals number of OH's MUBVUB. We're trying to solve for moles of acid. Well, MAVA is the same thing as moles of acid. So we need to solve for that. Divide both sides by number of H. Say goodbye, say goodbye. Moles of acid equals 2 OH's in the formula of the base. The molarity of the base is 0.100 molar times 0.0500 liters over 1 hydrogen in the formula of the acid. And this comes out to 0.1 times 0.05 is 0.005 times 2 is 0.01. 0 moles. 3 sig figs, 3 sig figs, 3 sig figs in the final answer, because remember these aren't measurements, so sig figs don't apply there.